So in this video, I'm just going to talk about what I expect for the rest of the report. So obviously we're investigating the pulling force on a trolley and how that will affect the acceleration of the trolley. And we're actually going to try and verify Newton's second law of motion, which is that the force applied to an object is equal to the mass of the object multiplied by the acceleration of the object. And we use the weight force of the object to calculate the force applied. And we use this equation of motion to calculate the acceleration of the trolley. So we changed the masses, applied different forces, and we measured the time taken, and from the time taken we worked out the acceleration. So you all should have your data table and a graph. And last lesson you were working on an introduction, so basically just describe the physics that is being investigated, so you can use my introduction to help you with that and expand on it. Hypothesis is an if-then statement. So we talked about that the independent variable was the one that you were changing. You were changing the force applied, and you were changing the force applied by changing the masses, the slotted masses, and that was applying different forces. And then the variable that you measured was the acceleration of the trolley, and you measured that by recording the time and then using the formula. Then you would have looked at control variables. So I told you to do that in a table. So the headings were just what the control variable was, how to keep it constant, and then how it would affect your data if not kept constant. Then materials list I've given to you, hazards you only need at 1 or 2. Procedure, basically I've given it to you, you just need to change it into past tense, so add ed, and if you made any differences to the method. So main focus is 9, 10, and 11. So in 9, table of results. Okay, so any calculations. So in your table of results, you calculated the force applied, which was the weight force, which was mass times acceleration. So you need to do one example calculation of that. And then for the acceleration, you use this formula, and you need one example calculation of that. Then obviously you had your graph, which you made on Excel, calculation of the gradient. Well, you can use the equation on Excel mode, and it was y equals mx plus c. And the gradient is the m value. And then you describe the trends in your results. So, as seen in figure 1 above, as the force applied was increased, blah, 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 blah. Describe the graph in your own words. And then a bit of a sentence interpreting the gradient. So talk about that the gradient represents the mass of the trolley. And then basically you need to have a sentence saying whether your hypothesis that you made up here was supported or not. And then you also need to talk about any physics concepts. So what should have happened was that the force applied to the trolley and the acceleration of the trolley should have been directly proportional, which is a straight line through the origin, but you might not have got exactly that. And then you need to talk about precision. So precision is the scatter in your results. How precise were your results? You need a description of the possible random errors and how they would have affected your data. You need an assessment of how accurate your results were. So how close was your gradient to the mass of the trolley? And then you need some possible systematic errors. So things that might have been incorrectly calibrated or things that might have been impacting on your data that you couldn't really control, but they were consistent. And then how they affected your data. And then any improvements. So this can be embedded. So you might have an error. So it might be, I'll give you one. Everyone's going to say the ticker timer. Not the ticker timer, the timer. So a possible random error was using the stopwatch as a timing device, and sometimes you might have pressed it too fast or too slow, so it was causing scatter in between your trials. And how could this be improved? Well, you could use a video, you could use light gates, you can Google how you could get a better time measurement. And then once you've done that, talk about the reliability. So remember, reliability is about whether you were able to reproduce the results. So random errors caused scatter and would reduce the reliability, and validity is about accuracy, how accurate your results were and whether there were systematic errors. And then finally, you just need a conclusion. describing whether the results do or do not support your original hypothesis, and justification. So whether from the data table and your graph, you're going to use that to justify whether your conclusion is true. So relate it back to your original hypothesis. And then I'm going to mark you on basically whether this is your hypothesis variable procedure hazards, your table and graph, your description of your graph and your conclusion, your evaluation, which is all your error analysis stuff, and then just your general communication. Obviously ask me for lots of help. The last thing I'll talk about is that it is a max 1,000 words. The materials, hazards, and procedure do not count because they're basically given to you and they never count in prac reports. Everything else counts. Delete all this heading, like you can have headings, but you don't, you delete all this stuff because this doesn't go towards your word count. But just have the headings. Ask me for lots of help. I need a draft by the end of the first week of the holidays. Cheers.